In this video, we will be discussing about neighboring bitwise XOR. A zero-indexed array derived with length n is derived by computing the bitwise XOR of adjacent values in a binary array original of length n. Specifically for each index I in the range 0 to n minus 1, if I equals to n minus 1, then derived of I is original of I XOR original of 0. Otherwise, derived of I is original of I XOR original of I plus 1. Given an array derived, your task is to determine whether there exists a valid binary array original that could have formed derived, return true if such an array exists or false otherwise. So what they are saying is that in the input, we are given an array known as derived. Now this array derived have been created from an array which is known as original. Okay, there is an original array which is a binary array. Then that means it consists of only zeros and ones, right? So there would be some values in that original array. Now, this particular array derived has been derived from the original array, and how it has been derived. So every element in this array is the XOR of adjacent two elements in original. So basically, one is the XOR of x1 and x2, right? x1 XOR x2 is 1. Then this one is the XOR of x2 and x3, and so on. And for the last element, this is the XOR of x3 and the first element. So basically, this is cyclically we are considering the next element as the first one. So this last element will be the XOR of x3 and x1, right? So this is how this particular array has been derived from the original array, right? Now, what they are asking is that you are given only this particular derived array. Now, if there is some original array from which we can derive this, then we need to return true in our answer. Otherwise, we need to return a false. So basically, if this derived array is a valid array, we need to return true, otherwise false. And when is it going to be valid? When we have an original array from which we can derive this particular array, right? So for this derived array, a potential original array could be, I guess, 0, 1, 0. How? So see, in XOR, we have four properties. 0 XOR 0 is 0, 1 XOR 1 is also 0, and 0 XOR 1 or 1 XOR 0, both of these are 1s, right? So see, this one will be the XOR of 0 and 1, which is 1 only, and that is what we have here. Then this one will be the XOR of these two things. So is this 1 XOR 0, which is 1 only, and that is what we have here. Then this 0 is XOR of this element and this element, right? 0 XOR 0 is 0 only, and that is what we have here. So this is one of the possible original arrays for this derived array, right? So this is valid. So in this case, our answer is going to be true, right? Now, if let us suppose I invert this particular array, invert meaning I change all the zeros to ones and ones to zeros. So it will be 1, 0, 1. Now, can this be the original array and can we derive this array? So see, this one will be the XOR of these two, 1 XOR 0, which is 1 only. Then this one will be the XOR of this 0 and 1. 0 XOR 1 is 1 only. Then this 0 will be the XOR of 1 and 1, which is 0 only, right? So then that means this could also be a possible original array for this derived array, right? See, we need not to necessarily find out the original array. We just need to return true or false, right? But to understand the intuition, that is why we are considering this, right? So in this particular case, answer is true only. But if you see that if I have an original array and if I do its invert, then also I'm able to derive this, right? So here 0 could also be there or 1 could also be there, right? In both the cases, it will work. So what I will do is that I will try to check whether from this derived array, I will try to create original array by keeping the first value as 0. We can also keep the first value as 1, but we will be considering the first value as 0, right? So what we'll do is we will consider the first value as 0, and now we will check in derived. So in derived, the first element is 1. Now in an XOR, when do we get a 1? When both the bits are different, right? So then that means if I have a 1 over here, then whatever is the last bit, next bit has to be the opposite of it. If it is 0, this has to be a 1. If it is 1, this has to be a 0. Only then I will be able to get a 1 over here, right? So whenever we have a 1 here, this particular bit will be the opposite of the previous bit, right? So this was 0. So here we will have a 1. Then again we have a 1. So this particular bit has to be the opposite of this bit. So here we have a 1. So here we will have a 0. Then for this 0, whenever we have a 0, our bits have to be the same, right? So whenever I am getting 0, then whatever is this particular bit, its next bit will also be the same, right? So here also I will have a 0. Now I am done with the derived array. Now whatever is this last element that we have get after we are done with the derived array, this particular element should be 0 only because that was our first element, right? Our original array is going to be this much, right? So this particular value that we are getting, this should be the same as the first element, and the first element we have always considered as a 0. So at the end we should get a 0. If we are getting, then our answer is going to be true, otherwise it is false. If you keep 1 over here, then at the last you should get a 1 for returning true, right? So basically what you can do is that you can create a variable last and initialize it to 0, and then you can start traversing in the derived array. So we have a 1, so then that means this will be inverted, so it will change to 1. Again we have a 1, this will be inverted, so we will get a 0. Then we have a 0, so this will remain the same, it will remain 0 only, and then we are done with the derived array. Now we need to check that if the last is still 0, then the answer is true, otherwise it is false. So this is what we need to do. Here we will just iterate once in the derived array and we won't take any extra space. So the time complexity will be order of n and the space complexity will be constant. So let's quickly look at the code. So first of all, let's take the last variable and initialize it to 0. Then we will run a for loop in the derived array. So int d in derived. Inside this we will check that if d is 1, then in that case our last will be inverted, right? And then at the end we can simply return last equals to 0. So if last is still 0, it will return a true, otherwise it will return a false. So this is one approach for solving this. Now there is one more approach with which we can solve this problem. So let's look at that approach as well. So see, if my original array is x1, x2, x3 and my derived array is, let's suppose, d1, d2, d3, right? So d1 will be the XOR of x1 and x2, d2 will be the XOR of x2 and x3, d3 will be the XOR of x3 and x1, right? This is what will happen. Now I am having multiple equations over here and I only know the values of these things. I do not know the values of x1, x2, x3, right? So what I will do is I will try to combine all of these equations into one equation, right? So for combining them into one equation, what I will do is I will take the XOR of all the elements on the left and all the elements on the right. Basically, I will do D1 XOR D2 XOR D3, and that will be equals to X1 XOR X2 XOR X2 XOR X3 XOR X3 XOR X1, right? So basically what will happen is this equation will look like D1 XOR D2 XOR D3, and this will be equals to X1 XOR X2 XOR X2 XOR X3 XOR X3 XOR X1. This is what our equation will become. Now in the XOR, we know that whenever our bits are same, right? Whenever we are doing A XOR 0, we will get a 0. So if you see over here, each of the bit of the original array, x1, x2, x3, that is coming 2 times, right? And when it is 2 times, their XOR will always give me a 0. So they will cancel out, right? So this x2 will cancel this x1 will cancel this x1, and this x3 will cancel this x3. So all the elements on the right have been cancelled. So we can say this will be equals to 0, right? So what we can simply check is that whatever is the derived array given to us in the input, if the XOR of all the elements of the derived array is 0, then our answer is true. Otherwise, it is false. So this is also one of the possible ways for solving this problem. Here also, we will be finding out the XOR of all the elements by iterating once. So the time complexity is still order of n and space complexity is still constant, right? So that's just one another approach for solving this. So let's look at the code for this as well. So first of all, let's create a variable XOR for storing the XOR. Then we will run a for loop in the derived vector, and inside this, in the XOR, we will do the XOR of D, right? And at the end, we can simply return XOR equals to 0. So let's run this. So the test cases are accepted. Let's try to submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.